30 seconds.
All
Right. So Jacob, hopefully you were able to watch the video while you're on the bus. Helped with hail, trying not to die.
Our fridge is over.
Hey, Jacob, come right here.
No, and our flag.
So I left.
Charlie, our flagpole broke.
I know you told me about it. Where was that at?
I came into Johnson.
It was like,
I
we were just outside the party and like there was like,
go back to the
yeah, there was like a 20-second period of time where we really couldn't see anything.
Yeah,
It was just like there was so much dirt and stuff.
Yeah.
My neighbors could be seen.
All of them in the brush.
I didn't say that was the last day.
It was about like this.
I heard it.
Yeah.
I didn't hear it. Very short. I woke up with lines in my face. That's the news thing.
Yeah, but it was about this.
But usually good people fly across your face until it's
Slop.
That's not you.
That's not you.
Grace is gonna be dead.
All right. Let's get your homework out here. Get your homework out, please.
So I shall.
When, Jacob, so Saturday and then we win, then what? Tuesday.
That's a weird stuff.
Okay. So, as we look ahead to next week's schedule, I think we're going to have kind of a final exam. So we're going to do our quiz on this stuff on Monday. It's something we decided yesterday for you guys that were not here. So we're going to do that on Monday. A lot of review time today. Then probably a couple days of review, and then thinking about. Got a choice on the final.
So last quiz for the
This will be the last quiz for the final. Okay.
I've got to leave the rest of my
What do you consider?
because I'm going to copy.
Like, is it everything to I'm
So, kind of, there's a chance. Nice try. See, I almost go for that.
I have a text from my mom.
3. I'm just. So there's a good chance we may do our final next Thursday.
Why are we doing
Wait,
science?
is that when your final?
That's our
Yeah.
chem final.
Chem
Please
final?
don't.
Oh, good.
Yeah, but it's due Monday before we're gonna study.
What is a final?
Friday.
Final Friday.
It could be Friday. I mean, there's people state track.
I'll take my finals Saturday. Just push through it one day.
Yeah, I mean that. We'll see.
What if we just did it today?
But that's kind of the.
Are you serious?
That's kind of the plan.
Even better.
Okay. All right. So anyway, let's move on. Let's focus on this stuff, this part of it now. So the main emphasis on the quiz, arithmetic and geometric sequences of series, but there could be some sequences. Remember, the very first thing we learned about was just sequences in general, right? Remember, arithmetic and geometric are just two subsets of a whole category of sequences, right? They're just the ones where you have a common difference, like arithmetic sequences, and that's where you add on the same thing to get the next term for each term after. And then geometric is when and this is the two different formulas we have for the nth term of an arithmetic and the sum of an arithmetic. And then the geometric is when you multiply by the same term. Now to find that common difference, you could subtract backwards, A2 minus A1, A3 minus A2, A4 minus A3, so forth, so on. Or for geometric, we can divide backwards to find the common ratio, is what that's called. A2 divided by A1, A3 divided by A2, A4 divided by A3, and so forth. In other sequences, like say perfect square, 1, 4, 9, 16, 25, right? Then that's just, that has no name, really no special name, that's just a sequence, right? And So there could be some questions about those, like find the nth term formula and try to, be creative and try to figure out the pattern. If it's not one of these two, come up with the formula. So we did some of that early on. And there may be some questions on that in our review, although most of the reviews over the arithmetic and geometric. Okay? And then these were the two formulas we had for geometric sequences. Mrs. Payne went over a couple days ago. So the nth term formula, well, actually there's three of them. The nth term formula is this one. Now, for you guys who were on yesterday, we talked about how this is very closely related to the arithmetic sequence formula, right? The arithmetic sequence formula, if we look at it up here, is you start with the first term and then you add on how many common differences for the nth term. Well, to get to the second term, you add on how many d's? 1. To get to the third term, how many d's do you add on? 2 onto the first term, right? To get to the fourth term, you add on 3 d's. So it's always one less than the term you're trying to get to. So you add on n minus 1 d's, right? So you take the first term and you add on n minus 1 d's to get to any other term you want. Well, if you look at this, it's the same thing, except you're multiplying. So to get to the nth term, you take the first term and you multiply by, so if you want to get to the second term, you multiply by what? R 1 time. If you want to get to the third term, you multiply by R 2 times. R times R would be R squared. You want to get to the fourth term, you multiply by R 3 times, right? 1 less than the number of the term you're trying to get to. So if you're trying to get to the fourth term, you multiply by R 3 times. So if you're trying to get to the nth term, you multiply by R n minus 1 times. So they're very, very similar in the way they operate. But you're not going to have to memorize them. I will put these on the quiz. Okay, there'll be a heading that says arithmetic, and it will have these two formulas. I'm not going to have the description of them. You'll have to know which one is which. Okay, it'll just be what's in the box here and here under the heading arithmetic. And under the heading geometric, I'll have this in a box, and that one, right? And you'll have to know when to use which one. Of course, this is for a finite number of terms that you're trying to add up. In a geometric series, you use this. And if it's an infinite geometric series, of course, there is no number of terms to plug in, so there's no n in the formula. And you just need the first term and the r. Okay? And of course, if the series is just getting bigger and bigger and bigger, and r is greater than 1, then there is no sum. And we say the series diverges. Okay, so those are the main things we were talking about. Now, before we get into the homework, I want to do talk about a couple of different things here, and then maybe do a warm-up set of questions. So those are the formulas, and certainly want to encourage you to use the formulas. You remember the very first day when we were doing arithmetic, and there was some confusion on some of the questions. You weren't sure what to do, and I said, use the formula. Use the formula. That's what you got it for. Okay. However, I also want you to understand what's happening, and it's possible you can do a lot of this, answer a lot of these questions without just plugging into the formula. Okay, just kind of some common sense. That's really where the formulas come from, just like I was just showing. Okay, so let's say you had this problem here. Now, it could be given to you in a couple different ways. You're told it's arithmetic. Maybe you're given this. A3 is 6, A7 is 18. Or maybe you're just given it like this. Now, to be honest, if I was given it like this, I think I might write this out. Oftentimes, if I'm not sure what's going on with the sequence or something, I'll write it out like this and put the blanks in between. Okay? So, what kind of question could you be asked here? Find the first term, right? Fill in the blanks. Whatever. Find the terms between 6 and 18. There'd be a lot of different questions. Find the common difference. Find D, right? Those would all be questions you could be asked on a problem like this, okay? So one way to do it, let's do it in blue here, would be to use the formulas. Which formula and what would I put where? Somebody want to take a crack? Which formula would be the applicable one that I can use here?
I don't think this would be right, but You take 18 minus 6 over 7
Okay,
minus
time out.
3.
Time out. We're going to do something like that. First, I want to use just the formula. We're just going to do straight formula. Which formula would I be using? This one that we were just looking at, right? This one here. Okay, so one way to do this would be to just pretend that this was your sequence, at least in the beginning. Does that make sense? Now, that's something I haven't talked about yet, but it's certainly a valid thing to do. Just pretend this is your sequence, okay? And let this be 1, which means this one is 5, right? So the first one is 1, and so now the 6 is what I could put in for my first term. And my n would be a 5, right? Because this is my fifth term, and what would go over here? 18. Now, except you're going to end up saying it's just exactly what you were saying, but you were thinking more just kind of common sense kind of thing, which I agree. But if we want to use the formula, it would have to look something like this, right? Because the formula needs a 1, and you don't have an A1, so you might be thinking, well, I can't use the formula then, and then I can see where that would lead you to be confused. You think, well, I don't know A1, and so I don't know the formula, or I can't use the formula, right? But you can use the formula, because you can always make any term you want the first term and just look at that part of the sequence, okay? Well, so what do we get for D then? So we get 12 equals 4D, we get D equals 3, okay? Well, what does that tell you? Well, now you know 9, 12, 15, you know, that's 3, you know, that's 0. And then depending what the question was, you'd be able to answer. What's the first term? Well, the first term is 0, okay? I know I was pretending 6 was the first term, right, to use my formula, but to answer the question, what's the first term, it would be 0. Okay, what are the terms in between, or whatever. What was common difference? Common difference was 3, we could get all that. Okay, now Seth, explain where you were going with what you were doing.
So basically just find the difference between each one. So 18 minus 6, and then 7 minus 3 on the bottom. So you get multiplied by 4.
Okay, so I remember Noah mentioned this one time. We were talking about how it was almost like a slope formula, right? Remember we said D is like a slope? So if you were giving these numbers right here, right, instead of giving it like this, instead of giving this, right, if you were just given this, then I like that idea of thinking that as a slope. 18 minus 6, 7 minus 3, right? Because that's really what you're talking about. Because that's what we talked about, how that's what D is like the slope. It's the rate of change of each one of those. And so you end up with 12 over 4, which is 3. Well, that tells you that there's a gap of 3 in all of these. And so once you find that common difference, boom, 9, 12, 15, 3, 0, you would have it, okay? So, but let's say it wasn't written this way. Let's say it was written this way. So see what I did with the plus D. We did that yesterday, I think, on one of the problems we were talking about. So this is another thing you can do when you have the sequence written out and you know it's arithmetic. You're going to add D, add D, add D, add D. Well, how many Ds? There's 4 Ds there. So can't you just go 6 plus 4D has to equal 18? Doesn't that make sense? Just from a kind of a common sense kind of point of view. Well, look what we had right here. Right? Same thing. Same thing. But you could look at this and say 6 plus D plus D plus D plus D is going to give me 18. And then you solve it from there, you get 3, and then away you go. Okay? All right, so let's look at this as let's say you had a geometric. Okay, let's say you had the same scenario, and it was a geometric. Well, let's go through the same process we just did. First of all, let's use the formula. Okay, well, the formula, unfortunately, says a sub 1. Right, to the n minus 1, right? However, let's just pretend this is the first term, which would make this the 5th term, right? So we'd have first, second, third, fourth, 5th term. So we could say the 5th term, 3, 4, 5, 6, is equal to the first term, 24, times r to the 5 minus 1, right? Because remember, this term has to match the n value over here. So if this is the 5th term, that's what we're calling it, at least in the beginning here to pretend, first, second, third, fourth, 5th term, right? Then we can put a 5 right there. Now, if you're saying, no, that's the 7th term, you have to put a 7 there. That's fine, but then you can't put a 24 here. That's got to be your first term. That would have to be this term. right? If you're gonna call that one the 7th term. It's called the 5th term, call that the 1st term. Okay, what would we do first here now? What do you get? 144 equals r to the 4th power. Okay? So now let's talk about this because you're going to get to use your calculator, but on some of these problems, if I don't say, if it's not a decimal problem, which this one is not, there are no decimals in this problem. Yesterday what we said is, if there's decimals in the problem, you can have decimals in your answer. But if there's not decimals, then we want exact values, or it may say exact values. So that means it might be square root, stuff like that. So how could you do this? If you try that on your calculator, what do you get?
324.
That's not good, is it? So you better figure out what that number is. Okay? Well, what's another number that's, it's square root of 12 is what it is. Now, how'd you get that? Okay? Couple ways you could think about this. You could say to yourself, okay, that r to the 4th is r squared squared. Is 140, I think is what you're saying. Now square root both sides. What do you get? 12 equals r squared. So r is going to be square root of 12. Okay, now a lot of times we would write, here's where it would be nice to write square root of 12 as, I wouldn't make you do this, but 12, that is what? Square root of 4 times square root of 3? 2 square root of 3. Okay, it would be nice to write it as that. So our r is actually 2 square root of 3, and I would want that number. I wouldn't want a decimal here on this problem. Okay, now another way you could do that is you could say, okay, that's the 4th root of 144, and I know you guys did a lot of this last year. What can you do if you're doing the 4th root of 1.4? Well, you can do that, right? Remember doing that? Okay, or you could do it as 144 to the 1/4 power. And remember, power on power, you multiply. Okay, so you can make this, and hopefully you'd recognize one. I would make it work out fairly nice, like this one does. That's 144 to the 1/2 to the 1/2. I mean, so there's a lot of ways to think about it, all related to square roots. Okay, so I would make it work out so it wouldn't be some weird cube root of something to the 5th power or something bizarre like that. Okay, but something like this could happen. Okay, and there'll be some easier ones too. So 2 square root of 3 is your r. Now, if you want to have square root of 12, I wouldn't count that against you. So what's the next term? 48 root 3 would be the best answer, but you might have 24 root 12. Let's say you just called it root 12, right? And then you would multiply by root 12 again. Now, again, you can use your calculator. Well, if you take 24 root 12 times root 12, the root 12s end up just making 12. So it's 24 times 12 is 288. And then the next one, you could have 288 times root 12. I'd be okay with that. Okay. Or if you multiplied by 2 root 3, this would be 48 root 3 times 2 root 3. Well, the root 3 times root 3 would make 3. 48 times 2 is 96. So you could have 96 times 3. Well, that's 288. And then here you could have 288 times 2 root 3. Well, 288 times 2 is what? 576. So this could be 576 root 3. Could have went here, or it could have been 288 root 12. Take either one of those. And then you multiply times 2 root 3 again, and you get that. Going backwards, you would divide. What's 24 if you were supposed to fill in these blanks? What's 24 divided by 2 root 3? I would take that. I would want you to reduce that. I would take 12 over root 3. Or, what do you do with that? You take root 3 times root 3. So that'd be 12 root 3 over 3, which is 4 root 3. So 4 root 3 would go here. And then what would go here? Well, 4 root 3 divided by r, 2 root 3 is 2. Right? There would be those terms. So I wanted to pick one out that was a little trickier, but it's more tricky for the little bit of algebra arithmetic, really, not the other part. But, okay, so it could look like that. Now, that's using the formula. Okay, now it'd be very, as we just saw in the last problem, be very similar in how you would do this. You would say, okay, this is, remember how Seth said take this minus this on the last problem? Well, what would you do instead? You would take this divided by this, right? And then that was times r, and then times r, and then times r, and then times r. Well, look what you got. You got 24 times r to the fourth has got to give you 3, 4, 5, 6. So again, same thing we came up with here. Okay, you just got to think about it. Times r, times r, times r. Okay, so that's, and then of course you would get to the same place. All right, so that would be one of the trickier ones you have to deal with in finding that, but that's something we want to be able to do. Okay, let's just a couple other practice things that could be on the quiz. Let's take a minute to work through those a little bit. Notice on 2 there, not 2, 3 and 4, write the first 4 terms of the sequence, and it says in 4 that it is arithmetic. Now, if you have a D, if you're given a D in a problem, you assume it's arithmetic. If you're given an R, you assume it's geometric. Okay? So there you go. There was your answer, and everybody's here anyway. So, all right. So, right, and so 3x's. So if we had to find the common difference, we could do that. Right? Any questions on those? All right. What about this last one? What'd you have? Nth term formula. What'd you have?
9 times 2.
9. So the simple way to do it is recognize it's a geometric sequence, right? Recognize it's a geometric sequence. 9 times 2, 18 times 2, 36 times 2. You're multiplying by 2 every time. That means r is 2. And so the nth term formula for a geometric sequence is a1 times r to the n minus 1. That's just what it is. That's one of your formulas we have. It's the nth term formula. So it's simply 9 times 2 to the n minus 1. Now you can check it, put a 1 in, it works. Put a 2 in, it works, and so forth. Now, if we had had this question the beginning of the week, we didn't know about geometric sequences, right? So when we were asked to do an nth term formula, we were just looking for a pattern. And repeatedly multiplying by 2 made us think of what? Powers of 2, right? 2 to the whatever. So you might have started this one. So what I want to show you is you could have had a different answer maybe than this. Well, it probably wouldn't end up being a different answer. But the process might have been a little different, a little trickier, but you might have started, okay, this is going to be 2 raised to something. Well, what you want to look for then, since if you notice that, wait a minute, these aren't powers of 2, 9's not a power of 2, 18's not a power of 2, 36's not a power of 2, so then now that gets a little trickier. Well, what you would want to do then, in that case, is you'd want to make this times powers of 2. So in other words, this is 9 times 1, I don't know about that one. This is 9 times 2. The next one is 9 times 4. The next one is 9 times 8. Now you can start seeing the powers of 2. You're like, oh yeah, I get it. That's 2 to the first, that's 2 to the second, that's 2 to the third. So this one is 2 to the 0, right? So then it's like, okay, this would be 2 to the n minus 1, and then we would times by 9, and you get the same thing. But that's how you would have thought through that pattern before. We didn't do a lot of those because I knew we were going to learn this formula, so why mess with that? So the best way for sure is to just use your recognize as geometric and use that pattern there. Okay, homework questions. Homework questions on section 9.3. Some of you, if you're gone, you got some makeup work to do here to get caught up on some of this. Which one? 89. What's 89 say? 2 minus 1/2 plus 1/4, 1/8. And then what's the last one? 2048. So we have, what do we have here? We have a geometric where r is negative 1/4. Now, how do we get that? Well, it's in the geometric section, but if we're doing this on the quiz, you would divide backwards. If you want to check to see if it's geometric, divide backwards. What's 1/8 divided by negative 1/2? Invert and multiply, that's negative 2/8, which is negative 1/4. divide backward. Now you can do this on your calculator too. Negative 1/2 divided by 2 is negative 1/4. Okay, R is negative 1/4, but you can divide backwards on your calculator. You're going to get negative 1/4 every time. Okay, our formula for a sum is A1 times 1 minus R to the n power, right, over 1 minus R, right? That's the formula we're looking for, the sum formula for a geometric, okay? We need to know how many terms that is. So how do we get that? How could we get that? Just keep multiplying out. How many is it? 7. That's the 7th term. Okay? You could, there'd be a lot of different ways you could do it, but one way would be what we were just talking about. You could say, okay, this is a term, we don't know what it is. Okay? First term is 2 times negative 1/4 to the n minus 1. Now, how did we talk yesterday about solving this? Divide both sides by 2. Okay, so that becomes 1 over 4096 equals negative 1/4 to the n minus 1. What do we do with that now? Do a log. Oh. Okay, so you're going to run the problem. You're going to get an error from the log. Okay? Okay, great. Okay, so anybody got that thought?
I just
No.
put the negative one. So
Well,
it worked.
yeah,
So
just ignore the negative. In other words, what's the negative really mean in this sequence? It's alternating. It's just alternating negatives. The numbers aren't changing, right? The numbers are going to be the same. Now we have to use the negative 1/4 in our formula, right? Because clearly the negative makes a difference in the sum, right? If you 2 plus negative 1/2 is a lot different than 2 plus positive 1/2, right? So we have to have the negative in there, okay? Here, but we don't have to have it here, okay? We don't have to have it here because you can't do a log with that. But all we're trying to find here is how many terms does it take to get to that. The negative has nothing to do with that. Okay? All right. So we can take that out of there now, and then that probably is okay. So now that'd just be log base 1/4, right, of 1 over 4096 equals n minus 1. Okay, now in your calculator, you can just take log of this divided by log of that. Remember, change of base formula. You can do any old log you want. I like ln. ln of 4096, 1 over divided by ln of 1/4. See what that gives you, and then add 1. No, you look.
yes, we did.
Okay. All I did is I did my nth term formula. The nth term is this. First term is that. Common ratio is 1/4 because we don't care about the negative to the n minus 1. So I just did that. Now, to solve an equation like this, to figure out what n is, I'm going to divide the 2 over here. That's what gave you that. And now, we learned last chapter, to solve an exponential, turn it into a log. Just turn it into a log.
Okay.
So log base 1/4 of this equals n minus 1. That's all we did. Or you can do the log of both sides if you want to do that, right? That's what we did in the last chapter. Okay? And so we get this. So now in your calculator, that's just change of base. So ln of that, add 1. What'd you say it was? 7. Once you get that that's 7, now you're adding up 7 terms. Now you just type that right there. And what was the answer?
It had it in sigma notation for the answer. Yeah.
Oh, well, see, there you go. I didn't read the directions. Okay. Okay. So anyway, that was good practice because that definitely could be a question we have to do is that. So now let's talk about the sigma notation. Okay. The sigma notation is simply the nth term formula, right? Remember, for a sigma notation, any sigma notation, what goes here is the nth term formula. Okay. So what did we say the nth term formula was? It was right there. So 2 times negative 1/4 to the n minus 1. And then n would go from 1. And then what do you need to know here? That's why you have to do the same solving. So it'd be the same process. You need to know how many of those terms you're adding up. We're adding up 7. And again, double check. Put a 1 in here. 1 minus 1 is 0. This to the 0 is 1. 1 times 2 is 2. So there you go. First term is 2. Okay, put a 2 in here. Negative 1/4 of the first times 2 is negative 1/2. There it is, right? I mean, so, but you needed to know, the key is you need to know what term is that last one. So that's this process here. Okay? So yeah, that's fine. Yeah, right? Summation notation. Again, to take a sum and put it in summation notation, all that means is your nth term formula goes here, and then you figure out how many terms you're adding. That's all. Okay? Anything else? Anything else on the whole? 105. And that just said find the sum. We didn't have to put it in summation, but we could. So 105, read that. Do you have your book there, Jack? What do you have? 1/9
minus 1/3 plus 1 minus 3.
Okay? So it's infinite, so it's geometric. We need to divide backwards, right? So negative 3 divided by 1, that should be our ratio. 1 divided by negative 1/3 is negative 3. There you go. So our R is negative 3. So we know R is negative 3. Well, what's a sum if the R is negative 3? Can't have a sum. Did they say no sum there? It said no solution in the back. Yeah. No solution. Because remember, R has to be less than 1. That means R has to be between 1 and negative 1. So it has to be a fraction. I had this right back here. It has to be like 1/3, 1/2, 2/3, something like that. How come?
Because it just keeps growing.
Otherwise, these terms are just going to keep getting bigger and bigger and bigger, and our sum is just going to keep growing. Right? If you have something like 1/3, right, then this part, if you have something like 1/3 to a great big power, this goes to 0, we said yesterday. So this whole parenthesis here will just become 1. So that's why we get A1 over that. Okay, but if R is bigger than 1, then this just keeps getting bigger and bigger and bigger. Okay, so that's why that is no solution. Okay, otherwise you'd end up with, if you tried to do the formula, you'd have 1/9, you'd have 1 minus negative 3, you'd have 1/9 over 4, which is 1 over 36. Well, if you start adding this up, there's no way that's what it ends up to. This formula just does not work unless R is less than 1. Okay? No solution. Now we could write the nth, if they had said, right, put this in summation notation, we could have done that. What's the nth term formula? It's 1/9 R to the n minus 1, right? That would be the nth term formula of that thing, using the nth term formula we're given. And n would go from, usually we use I here, but n's okay. 1 to what? Infinity, right? They don't give us it's infinite. That would be the sum, that would be the summation notation of that thing. But there is no sum. Okay. All right, anything else? Okay. Well, if you come up with something, let me know. We're going to have a lot of work time now, the rest of before lunch and then after lunch. Got 2 worksheets here, 2 review sheets. We'll start with this one. Arithmetic on one side, geometric on the other. Oh, it is Clay's birthday, yeah. So it's Friday. It's our second last Friday. Oh, first semester? Second semester? Yeah, you're welcome.
Someone from my grade, really.
Yes. Your second to last Friday of this year.
I know. I still got a lot of Fridays left.
This school year.
Next year is going to be very.
For some of us, it's the second to last Friday. Never.
Next year's going to suck. Really?
I mean, there'll be more Fridays.
Just as a teacher.
It's just that every day will feel.
You going to stay in the subbing routine or you just.
God, no. Like I'm more.
Like you staying?
Yeah, I say that, I probably will end up, but need some money.
Watch the new house will be gone and
Yeah.
he'll come back and he'll be like, why can't you just be our teacher?
Oh, yeah, right.
Who's gonna be the cat teacher, you know?
Mrs. Gardner. She's a nice teacher.
Oh, I was like, I have no idea.
Yeah, she's a young teacher. She's good. She's a good teacher. Yeah. If all I had to do was set for a cow, or honors management,
You want something?
Folks,